Leetcode 849 maximize distance to closest person. So in this problem we are given an array representing a row of seats where seat of I equals to 1 represents the seat has been occupied by a person, and seat of I equals to 0 represents the seat is empty. So there are constraints that there is at least one empty seat and at least one person sitting. Alex wants to sit in the seat such that the distance between him and the closest person is maximized. So we have to return the maximum distance to the closest person. To understand this, let's pick one example. Given this example, Alex can sit on of the in any of the zeroth position, and we have to find the maximum distance. Suppose if Alex sits here, what is the distance between the person which is having the seat as occupied is 1 here, 3 here. So the minimum of these two is 1. The closest person to Alex is at a distance 1. So if he sits here, then the answer he get 1 as the distance. If he sits here, then this is at a distance 2, this is at a distance 2. So minimum of these two is 2. He gets 2 as the answer. So if he sits here, the minimum distance between the 1 is 1 here. So he gets 1 as the answer. If he sits here, then the minimum distance is again 1. So he gets 1 answer. He cannot sit here because these are all preoccupied. So the maximum of these is 2. So our answer is 2. Similarly, let's see another example. In this example, if Alex sits here, we can see the distance we get is 1, 2 and 3. Similarly, if he sits here, we can get the distance as 2. If he sits here, we can get the distance as 1. Since it is occupied, we can't do anything. If he sits here, we get the distance as 1. Occupied, we can't do anything. The maximum of all this is 3. Now for the third one, if he sits here, he cannot sit here, so it is 0. If he sits here, the distance is 1. If he sits here, the distance is again 1. If he sits here, is 0. If he sits here, it is 1. If he sits here, the distance is 2. If he sits here, the distance is 3. So the maximum of all this is 3. So we need to observe one case is that here these cases are divided into 3 parts. How these 3 parts are there? Firstly, if Alex sits on the leftmost part, so the distance would be the position of the first one, which is 3 minus 0, which is 3. If Alex sits at the rightmost one, the distance would be 6 minus the rightmost one, which is 3, 3. And if Alex sits in between the ones, the distance would be middle of this all zeros, which is 1 and 2. So the first case is if it sits on the left part. The second case is if it sits on the rightmost part, and the third case is if it sits in the middle. So for the first case, it is just finding out the first one index, first sitting person. So that index would be giving us the first sitting person index would be giving us the maximum we can obtain by making Alex sit at left. And for the rightmost, if we go to the rightmost one minus the rightmost position, then we will be getting the index where Alex can sit, what maximum Alex could get while sitting at the rightmost index. For the middle one, we will examine few of the scenarios, which is to find middle one, we will examine this of the scenarios, which is 101. If we have two zeros in between, we have 3, we have 4, we have 5. So the middle between this zeros, it is quite intuitive that if we sit on the middle, the distance would be maximized. So if we sit here, the distance is 1. Here it is an even number, so if we sit here, then also it is 1, or if we try to sit here, then also it is 1. So we are getting both the position as 1, so minimum is 1. Since it is odd, we will try to sit in the middle and the distance will be 2. Since it is even, if we sit here, then this is the distance 2 minimum what we can get, and this is the distance 2, so our answer would be 2. Again, this case is an odd case. If we sit here, then we will be getting maximum 3, and now again it is an even case. So if we sit here, we will be getting this as 3, and if we sit here, we are getting again as 3. So here we can derive a formula such that if number of zeros is 1, we are getting the output as 1, index is 1, middle as, if number of zeros is 2, we are getting the middle as 1. If number of zeros is 3, we are getting the middle as 3, as 2, 4, then 2, then 5, then 3, then 6 and 3. So how we are doing this? We are taking this n by 2 of ceil. So n by 2 is nothing but for 1 by 2 of ceil is 1. Similarly for 2 by 2 it is 1. For 3 by 2 it is 2. For 4 by 2 2. 5 by 2 3. 6 by 2 is also 3. So a way of writing this is n plus 1 by 2. This will give us similar result as if we observe this, that 1 plus 1 by 2 for n equals to 1, it is giving us 1, and 2 plus 1 by 2, its integer value if we take is again 1. So this is our formula for the middle one. So now we are ready with all the three cases, which is first one, second one, and the middle one. Let's try to understand this with the help of the code. In this code, what we have taken, we are figuring out leftmost one, then rightmost one, then maximum, and then count. We are iterating through the array. For leftmost one, what we are doing is, if we have seen one time the one, the first one will be our leftmost one. So it would be like, since we have initialized the leftmost to -1, and we are changing the value, if it is not -1, we won't be changing. That is, we will change only if we see the 1 for the first time. For the rightmost one, we will be updating every time we see 1. So till end we can get the rightmost one where it is. For the middle, what we will be doing is, if the seat is 1, that is, we are in the start of the first one, and we will make the count as 0, and in between, if we see zeros, we'll increase the count as increase the count, which will be indicating the number of zeros we are counting. The next time we see 1, it means that we have counted all the zeros between two ones, and what we will be doing is, we'll be simply using our formula count plus 1 by 2, and we will be doing the previous maximum and the current maximum will be assigning. So these line number 14 will give us the maximum finding between the middle. We have to return the maximum between the middle in the leftmost and the rightmost. So leftmost is simply the leftmost one position which we have firstly taken. So we will be taking maximum between the middle and the leftmost, and the rightmost is seats dot length -1, because our array is starting from 0th index, and then we are minusing the rightmost one position. So this will give us the answer. Thank you.